boys and girls, this is Mrs. Wengervasio, and today we're going to be covering Chapter 5, Lesson 5.5 on slope. Reference pages to this can be found in your textbook, pages 194 to 195. As a reminder, don't forget to take down all the notes in today's video for full points in your notebook, okay? All right, let's go ahead and get started with some key ideas. So we're going to talk about what a slope is using this definition. So if you can make sure you copy down everything you see in this definition right box, I'm going to go ahead and circle or box for you right here. Okay, right there. So basically a slope is the rate of change between any 2 points on a line. So notice there is a line right here. I'm going to go ahead and highlight for you. There's a line right here. And a slope is basically the change in any 2 points. So if you look at the 2 points they have right here, they have one here and one here. And we want to know how much is it from here to here. So it is a measure of the steepness of a line. So a slope is the measurement of 2 points and its steepness. So I have here an example to remind you also what a slope is. So a slope is basically the steepness of a line. I have a skier here. We want to know how steep is the skier going down from the mountain. And to find a slope, you would need 2 points. The picture here doesn't show 2 points, but in my example here, it does. So here's 1 point and 2 points. All right, so to find the rate of change, as it's saying, to find the slope of a line, you need to find the ratio. So a slope is written, if you notice, in the form of a ratio. And I have here the slope of this line is 3 over 2. Now, the way they got 3 over 2 is they did a change in y first over the change in x. So if you can do me a favor, copy down this next part I boxed. Very important that you know that a slope talks about the change in y over the change in x. And particularly, you need to remember that it's always y over x first. And the reason why it's y over x first is because when we're trying to figure out from this point to this point, we go up and then we go across. So when we go up, that's a y, because this is our y, and when we go across, that's our x. So therefore, it's y over x. So again, how do you get from 1 point here to the top here? You can't just run across like that. You have to go up, which is y, and go over, which is x. Now, easy way to remember this is also not just y over x, but 2 words. Rise over run. I like to remember slope as rise over run also because it helps me to remember that slope is y over x. So take a look one more time. I'm going to show you. When you rise, that's a y. When you run across, that's a x. So therefore, it's called rise over run. Let's go ahead and do some practice with our slopes using this information that I just provided with you. So I have here example A and example B. So notice in example A, I'm going to go ahead and highlight the line for you. We have a line and there are 2 points. I'm going to go ahead and highlight the points for you. 1 and 2. And to find the slope of the line, as I mentioned in the previous page, you need to know that slope is y over x. Or I said you can always remember as rise over run. Whichever you feel more comfortable with. I just remember rise over run because it helps me remember that it's y over x. Sometimes students forget that it's y on top instead of x. So when we try to get from this point to this point, we're going to have to rise. And we're going to stop right there because the other point meets right there. Now what we're going to have to do is count how many units did we rise by. So we're going to count 1, 2, 3, 4. And we're going to stop right there. Since we went up, that's our y, our rise. And that was up 4. So we'll put 4 here. And then how many units does it take to get from here to here? That's going to be 1, 2, 3. And since we went over 3, that's going to be a positive to the right 3. So positive 3. So if you look at this slope now, it's in the form of a fraction. Again, a slope is also a fraction, a ratio. So now if I look at it again, can I reduce it? If I can't, that's my final answer. So this yellow line here in A, the slope is 4 over 3. Okay, let's go ahead and take a look at our second example. I have the line here. I'm going to do it in another color so you can see. and our point is right here and right there. So what we're going to do is we're going to try to figure out how did we get from this point to this point. Again, we can't just run up. We're going to have to do our rise over run. So from here, we're going to go rise 1, 2, and 3. And we stopped here because it meets with the other point. So since we went up 3, we're going to put positive 3. And that going up part, that's called a rise. And it was also a Y. Notice I'm just put a Y here so you remember. And then from here, we're going to run across 1, 2, 3, 4, 5, 6. We stop at the other point and we got to 6. And since we went to the right, it's going to be a positive 6. And remember, running across, that's our x. So that's going to be x at the bottom. Y is 3, x is 6. Now this one we couldn't reduce, but this one, if you can reduce it, let's go ahead and reduce it. If I reduce this, I can reduce it by 3, and I get 1 over 2. So my final answer for the second one is 1 over 2 as my slope. Again, the slope is actually also a ratio of y over x. Okay, all right, let's go ahead and have you do then these two problems on your own on a separate sheet of paper. Go ahead and try to figure out the slope of each line. And again, you're going to start from the bottom and going up to the top. But again, you just don't go across like this. You have to do rise over run. Same thing here. Rise over run and how many units. And make sure it's in a fraction form, y over x. Okay? And if it's too fast in this video and you need more time for this two problems, go ahead and pause it and then continue the video when you're ready. All right, in example 2, it's talking about a table showing your earnings for babysitting, and they basically want to know if your babysitting earnings is compared is if there's a comparison with your hours of work. So what we're going to do is we're going to graph this table. So we're going to go ahead and graph this first. I'm going to go ahead and graph it really quick with you. And if you notice, this is my x and this is my y. I'm going to study my x. It's 2, 4, 6, 8, 10. So I'm going to go by 2, 4, 6, 8, 10 on my x. 2, 4, 6, 8, and 10. Okay, and then I notice my y. Y is this way. Don't forget, it's going by 10, 20, 30, 40, 50. So I'm going to put 10, 20, 30, 40, and 50. And then now I'm going to go ahead and graph it as A says. So if x is 0, y is 0. I'm going to graph it another color. If x is 2, y is 10. And remember, don't forget, as your little reminder, this is always our x and this is always our y. Okay, and if x is 4, y is 20 right there. If x is 6, y is 30. And you notice it's forming a straight line. If x is 8, y is 40. And if x is 10, y is 50. All slopes should be a straight line. So I'm going to go ahead and connect this line for you and show you a straight line. And it should be on the point. And the reason why mine isn't is because I didn't use graph paper. I'm going to try to line it up as best as I could. Okay. So here it is. Here is the slope of the line. And now we want to find and interpret the slope. So basically they want you to find the slope after you graph it of the line. So again, to find the slope, you need to have, I'm going to go ahead and put it right here. You need to have it in the form of y over x. So I'm going to go look at my y. I'm sorry, I'm going to go ahead and look at my points. There's so many to choose from. Unlike the last example, we had only had 2, but this time we have a lot. So we just need to choose any 2, and it doesn't really matter which 2. I always, again, like to use small numbers, so I usually like to use the smallest points. And also, I'll show you in class later on when we do more practice, perfect points. What are perfect points? No decimals. So anyhow, I'm going to go ahead and show you that the rise for this one is actually 10 units. I don't have the 10 little tick marks here, but we are going up 10. So that's going to be 10. And my run, you can see if I have a 1 right here, it would be right here. I would run across would be 2 units, so my x is 2. Now, if 10 over 2 can be reduced, I'm going to go ahead and reduce it, and I can reduce it by 2. So my answer is 5 over 1. Again, a slope needs to be in a fraction form, so 5 over 1 would be our answer. Now, let me also show you another way you could have done this without graphing. So if you wanted to do this without graphing, you could have also just use the y over x and do this. I'm going to show you. You know that slope is y over x, so you could have just chose any of these sets. I'm going to go ahead and choose this last one. Again, it doesn't matter. When you choose a set, it has to be one x and one y. So what is our y? Our y is 40, so I'm going to put 40. And what is our x? Our x is 8. I'm going to put 40 over 8. And that's y over x. Now, can I reduce this? Yes. By what? I can reduce this by 8. And you get 5 or 1. So you still get the same answer as I did on top using no graphs, just using the information y over x. So you can do that to find slope. Remember, a slope is just y over x and rise over run. If you can remember for this lesson, you are a-okay. So what is slope? Rise over run, or we say y over x. Don't forget that. All right, if you can do the following two questions on the same paper as problems 1 and 2, go ahead and try 3 and 4 and answer those questions. Don't forget 4 has an A and a B. All right, last but not least, if you can do the exit ticket on this page and all the other questions we had for homework. So for a total of 4 problems and an exit ticket. Any questions you have in today's video, feel free to ask me them in class tomorrow and I'll be more than happy to answer them. Have a great day. Bye-bye.